Gotcha. Gotcha.
I keep hearing horror stories about our beautiful old buildings. Not only were they not built with energy efficiency in mind, but you might not even believe some of the things you're about to see. Now, the First National Bank of Grand Poobah isn't about to let us document the environmental disaster in their basement, but this is the old Simpsons building at Yonge and Queen in Toronto. It's now the Bay, and the Bay is spending a whack of money to undo the past.
What happened was the store started having cooling in 1919, and these went out in about 1960 or so. What these are the heat exchanger tubes. The water flows through them, mixes with the refrigerant, and it sends all the chilled water throughout the store. The evaporator, which was above it, then at this point, 75 years ago, was just cooled by city water. It was a very inefficient system. Once through, it used city water cooling, brought it in, cooled the refrigerant, and then sent it all down the sewer. Very inefficient.
Sending city water down the drain was de rigueur in the first half of the century, as you will see. Even though we use alternating current electricity for most everything, a lot of older elevators and hoists were direct current. DC was better in them there days for proportional control of motors.
This is an old DC generator that used to power the building for emergency lighting, hydraulic elevator that was here, and the fire pump when the city power shut down. It hasn't been run in a few years now. You can see the size of the generator on it. It feels as if you're walking into the hold of a ship when you're coming down the stairs and seeing this monstrous piece of equipment here. It's just fascinating. This is the old control panel, and it kind of brings back memories of some old Frankenstein and Dracula movies. This equipment was all installed in 1926, and it looks like it's, other than a little bit of dust, looks like it's in fantastic shape.
Can we open it?
Yeah!
You may not have known that 4-foot-high mercury vapor rectifiers existed. I knew that, but I didn't know there were any still in service.
Yeah.
Rectifier.
DC was, the majority of it was a large hydraulic elevator.
Yeah.
Water-powered hydraulic elevator. And we've got some supply fans, we've got a dumbwaiter. That's right. And this is what this is a mercury vapor rectifier that's changing the current from AC into DC. And it's got an old wooden fan here underneath it that apparently has been running for about the last 60 years and hasn't needed an ounce of maintenance. We've got about 6 or 7 of them down here. About 6 of them, and they're going to Ontario Hydro, the Smithsonian, Science Center. Almost every one of them has a future home. Unfortunately, I don't have room for it in the basement, and I'm not sure I really have a need for it.
My boss is going to ask me what the waste knot angle is on these babies. Well, Wally, that's 50 pounds of mercury bubbling away, and we were probably getting a tan while the door was open. Good enough? Let's do the steam next. To understand the steam thing, you have to know that a lot of buildings buy their steam the way we buy water and electricity.
Right, we find it more economical to buy steam from the Toronto District Heating Commission than to install a steam boiler. So we do use the steam mainly in the wintertime for heating the building, but we also use it in the summertime for the kitchen and cooking upstairs on the 7th or 9th floor.
There's a catch to buying steam. A normal steam boiler has a return loop. The steam condenses back to water in the radiators, and the water is returned to the boiler to make new steam. Not in this system.
I wonder if this is going to condense on your lens, or humid. It's pretty humid down here.
Yeah, it already has. My viewfinder's had it. Just a second. I'll just keep wiping it. Okay. I think you better tell us this story, because no one would believe it if I said it.
Well, we're 4 basements underground, and what's happening here is the building is all heated by steam. We buy the steam from the Toronto District Heating Commission and pump it through the building. When it goes through the rads, it gets a little cooler. When it gets even cooler again, it condenses. What we have here is the steam condensate coming down, but it's still around 180, 200 degrees Fahrenheit, and we're not allowed to pump or discharge water into the sewers above 120 degrees. So you're not going to believe this, we're flushing cold water over the steam condensate in order to get it down to discharge temperatures. And it's a complete waste. It's so inefficient. It was in place many years ago when the water didn't cost very much, but now they're charging us, and now we're investigating ways to not only reduce the cooling water, but to recover the heat from the steam condensate. So it's quite an engineering challenge for us. We're working on this one a fair bit.
If you're used to turning off the light when you leave the room, you might think of turning off some of the ventilation controls when you close this building. It's not so simple. There are dozens of fans on many floors, each with their own switch.
Let me just see the size of this. 60 horse. This is a 60 horsepower motor that's been running for years, 24 hours a day, 365 days a year, whether the store is occupied or not. It's an air supply fan, so it's needed to turn the air over when the customers are in the store. But at night, when everybody goes home and on weekends, afterwards, we have no need to run this. So what we're going to do is install a direct digital control system that will tie in all of the mechanical, electrical systems in this building, including this fan, and it's going to say, Tuesday night, the store closes at 10 o'clock, boom, I shut the fan down.
The DDC system will use its computer to manage all of the equipment and is smart enough to, say, pre-cool the building overnight using free cooling from outside.
So how do I get a plug-in for our company?
Since everyone was so accommodating, I didn't feel bad letting some PR sneak in, so I carefully phrased a question.
So in general, what does your company do?
Well, we're involved in energy management. Where the Energy Service Group, our backbone, Fabian Engineering, does all of the design and selection, and then our other company, Enertech Building Services, actually does the installing and working with the operators to save all the energy. Then as a group, we come together, work with Ontario Hydro, and see what type of incentives they can give us. For example, in this project, Ontario Hydro is kicking in $1.5 million to help us pay for all of the energy savings costs. It's a big project, and without Ontario Hydro's bump, I don't know if we could be able to afford to do this or not.
Most of the big work is taking place in mechanical rooms and basements. The visible part concerns 70,000 light bulbs. In the past, some architectural genius had installed 156 fluorescent tubes in each elevator well, then covered them up with some reverse louvers.
And that's a total of around 7.5 kilowatts for every single escalator bank. Now that was 78 fixtures, 2 tubes each. This is 20 tubes total with 4 ballasts.
And they're smaller wattage tubes as well.
Smaller wattage tubes as well. So basically we've gone from 7.8 kilowatts to 0.75 kilowatts, a 90% savings, and quadrupling the light level. And it looks a lot better too.
As well as the general lighting, display lighting needs to be changed. Display lighting is very important to retailers, so a demonstration area has been set up. The wattage has been reduced in this display by a factor of 10, using some 35-watt color-corrected high-pressure sodium lights. Yep, you heard right, sodium. And the color is very good.
Do you find there's any difference in the light levels in the store? Okay, be like that.
The retrofits at this bay location will reduce the electrical demand by about 2 million watts and shave $900,000 a year off the electric bill. The bay is to be commended for spending money on energy reduction where the customers can't see it. Have you found yourself wondering how many other old buildings have basements like this?